Early today, NOAA's Storm Prediction Center flagged a Tuesday severe weather setup. Scattered storms from the central high plains toward the plains and Midwest may produce hail over 2 inches and wind gusts greater than 75 miles per hour. One signal would be unusual. Several signals together are harder to dismiss. The official outlook carries a severe weather risk across the central high plains into parts of the central and southern plains. It names hail larger than 2 inches. It names wind gusts greater than 75 miles per hour. It also says models generally agree that afternoon storms may grow upscale into a southeast moving storm complex capable of damaging wind swaths. But that is not the most dangerous part. The headline is not only whether a tornado can form, the hidden number is how far the wind can travel once storms merge into a line. This is not a confirmed derecho, but it is the kind of setup where derecho-like wind becomes the risk people may recognize too late. This is not just a tornado setup. This is a wind swath infrastructure test. A tornado warning points to a smaller corridor. A damaging wind swath can cross roads, farms, power lines, homes, and small towns before the damage feels connected. So the question is no longer simply whether the Midwest sees tornadoes. The question is what happens when organized thunderstorm wind reaches the body. The hospital, the grid, the road, the farm, the water system, and the city. Like, subscribe, and comment where you are watching from, because this map is not only showing storms, it is showing where the first weak point may appear. But the first clue is not the funnel, it is the line. At sunrise, the official signal was already sitting inside the weather system. NOAA's Storm Prediction Center had issued a severe weather outlook for Tuesday and Tuesday night, placing parts of the central high plains, the central plains, and the southern plains under a setup capable of producing very large hail and destructive thunderstorm wind. By itself, that would be enough to watch. But by the time the morning forecast cycle was on the screen, the signal was no longer just one hazard. It was a cluster of hazards sitting inside one atmospheric configuration. Hail larger than 2 inches, wind gusts greater than 75 miles per hour. Isolated severe storms farther north toward the northern plains and the upper Mississippi Valley. And most important, the possibility that storms forming during the afternoon could merge, grow upscale, and become a southeast moving mesoscale convective system capable of damaging wind swaths. On their own, these signals could be treated separately. Together, they describe one larger configuration. This is where the day stops being a simple, severe thunderstorm forecast and starts becoming an operational dashboard. The first light on that dashboard is the risk area. It does not say one town. It does not say one county. It stretches from the higher ground of the central high plains toward parts of the central and southern plains, with additional storm risk extending northward into the upper Mississippi Valley. That matters because a severe weather day is not only defined by where the first storm forms, it is also defined by where the atmosphere allows that storm to survive, organize, and travel. The second light is the hail signal. The Storm Prediction Center specifically mentioned hail in excess of 2 inches. That is larger than a golf ball. For a farm, it is not just ice falling from the sky. It is impact energy on corn leaves, soybean fields, truck windshields, barns, livestock shelters, solar panels, and roofs that were never designed to take repeated strikes from frozen stones moving at highway speed. The third light is the wind signal. The outlook names gusts greater than 75 miles per hour. That number is not background noise. A thunderstorm gust at that level can snap limbs, push high-profile vehicles, damage outbuildings, bring down power lines, and turn loose debris into moving objects. It is the kind of number that pulls the road department, the utility crew, the farm operator, the emergency manager, and the hospital facilities team into the same forecast. The fourth light is the organizing signal. According to the Storm Prediction Center, models were in generally good agreement that afternoon storms could grow upscale into a southeast moving mesoscale convective system. That phrase sounds technical, but operationally, it means the forecast concern is not limited to individual storms rotating on radar. The concern is that storms may connect into a larger machine. That is the turn. A rotating supercell is frightening because it can focus violent damage into a narrow path. But a storm complex is frightening for a different reason. It can spread the burden. It can move from one county to the next, not as one obvious funnel, but as a wall of wind, rain, lightning, and falling pressure moving through towns that may only have minutes to understand that the hazard has changed. The map shows storms. But the system is beginning to ask a different question. Can those storms stay isolated, or do they merge? The answer changes everything. If storms remain isolated, the day is watched through the lens of individual cells. Forecasters look for discrete storms, inflow notches, rotation, hook shapes, hail cores, and possible tornado warnings. The public watches for the most dramatic hazard because the word tornado has a long memory in the Midwest. It has a sound. It has a siren. It has a basement. It has a mental picture. But if storms merge, the day becomes something else. The line becomes the event. The leading edge becomes the warning. The wind field becomes the damage path. The hazard shifts from one point on the map to a moving corridor of force. That is why this setup cannot be read only as a tornado setup. This is not just a tornado setup. This is a wind swath infrastructure test. Inside the dashboard, the setup begins with instability. Warm, humid air near the ground gives storms fuel. That fuel does not guarantee severe weather by itself. It is more like gasoline sitting in a system that still needs an ignition source, a lifting mechanism, and a way to organize the burn. Across the plains, that lift can come from boundaries near the surface, from a front, from outflow left by earlier storms, or from subtle disturbances moving overhead. Then comes wind shear. Wind shear means the wind changes with height. It may change speed. It may change direction. For severe storms, shear can help separate rising air from falling rain, cooled air, allowing storms to last longer and become better organized. In a tornado-focused day, forecasters watch low-level shear and storm-relative winds carefully. In a wind swath day, they also watch how the deeper wind profile may support a forward-moving system. Then comes timing. Timing is one of the most important parts of the day and one of the easiest to miss. Severe weather does not only depend on what ingredients exist, it depends on when those ingredients overlap. If storms form too early, they can spread clouds and rain over the risk area, reducing heating and limiting later instability. If storms form too late, they may miss the strongest daytime fuel but enter the evening with a different kind of risk. If a boundary sits in the wrong place by even a few counties, the corridor of greatest wind may shift. This is why the official outlook does not need to pretend certainty. It can identify the signal and still acknowledge the uncertainty. The Storm Prediction Center noted that uncertainty in the specific track of the possible mesoscale convective system prevented higher wind probabilities and an upgrade to a higher categorical risk at that time. That sentence is not weakness, it is discipline. It is the difference between a warning based on evidence and a forecast inflated for attention. But uncertainty in the track is not the same as absence of danger. It means the atmosphere has the ingredients for a damaging system, while the exact road that system may take is still being resolved. That is a hard message for the public, because people want a yes or no forecast. They want to know whether their town is in or out. But severe thunderstorm setups often do not work like that. The atmosphere does not always draw a clean line hours ahead of time. It builds a corridor through small changes in cloud cover, surface wind, moisture, temperature, outflow, and storm interaction. The day begins as probabilities. It becomes damage through placement. By late morning, the most important question is not only where storms will form, it is what the environment will look like after the first storms form. Earlier storms can stabilize one area and sharpen another. Rain-cooled air can lay down an outflow boundary. That boundary can become the next focus for storms. A cluster can send wind outward. That wind can lift warm air ahead of it. New storms can fire along the edge. The system feeds forward. This is how a dashboard becomes a chain reaction. A meteorologist looking at the setup is not simply watching a radar image. They are watching surface observations, satellite imagery, short-term models, dew point maps, wind profiles, mesoanalysis, warning history, and reports coming in from the ground. One screen shows cloud cover, another shows instability, another shows wind shear, another shows where storms have already left cold pools, another shows whether the atmosphere has recovered behind the morning activity. The public sees a colored area. The operations room sees a system trying to decide what it wants to become. There is a reason the day feels abnormal. It is not because severe storms in June are rare across the plains and Midwest. They are not. This is severe weather season. Storms belong on the calendar. The abnormal part is the stacking. Large hail potential is one layer, significant severe wind potential is another. The possibility of upscale growth is another. The downstream exposure into populated corridors, farms, highways, and power networks is another. One layer can be handled as weather. Several layers together become load. That load begins before the first warning is issued. Utilities start thinking about crew placement. Emergency managers watch for counties that may need shelter messaging. Schools and evening events look at timing. Trucking routes across open highways become more vulnerable if the wind hits during travel windows. Farmers think about equipment, irrigation systems, livestock, and fields that cannot be moved out of the path. Hospitals check backup power without necessarily announcing it. Dispatch centers prepare for the kind of call volume that arrives when trees, wires, crashes, alarms, and injuries happen close together. A damaging wind setup does not wait until damage is photographed to enter the system. It enters first as uncertainty. A county emergency manager sees the outlook and has to decide how much attention to give it. A utility supervisor sees the same outlook and wonders whether crews may be needed after dark. A family sees the severe weather risk and thinks tornado, basement, siren. A farmer sees the hail number and thinks crop damage. A truck driver sees a line of storms and thinks delay, crosswind, visibility, and whether there is a safe place to stop before the gust front arrives. Each person is reading a different part of the same forecast. That is what makes the setup dangerous in a quiet way. The hazard is not only meteorological, it is informational. People have to understand what kind of storm day this is before the storm day fully declares itself. A tornado threat is narrow enough to feel specific. A wind swath threat can feel vague until it is suddenly everywhere. That difference changes behavior. People know what to do when a tornado warning names their town. They may not know what to do when the warning says severe thunderstorm, destructive winds, and a fast-moving line. They may wait at a gas station canopy. They may keep driving under trees. They may stand near windows to watch. They may assume that because there is no funnel, the worst has missed them. But Derecho-type wind does not need a funnel to damage a community. It only needs a storm system organized enough to push air outward at destructive speed. That is the hidden tension inside the official signal. The outlook is not saying a derecho is confirmed. It is not drawing a finished damage path across the map. It is saying the atmosphere may support the kind of storm growth that can produce damaging wind swaths. That distinction matters. It keeps the evidence clean. It also keeps the risk real. The day is still forming. That is why the operational dashboard is so important. Early in the day, the map shows a risk area. By afternoon, the satellite will show where clouds have cleared or thickened. Surface stations will show where the dew points have pooled. Radar will show whether storms remain discrete or begin to cluster. Warning text will show whether the hazard wording shifts from hail and isolated wind to widespread damaging wind. Reports from spotters, emergency managers, and the public will show whether the atmosphere is only threatening damage or already writing it on the ground. The first reports may be small: a tree limb down, a measured gust, a county road blocked, hail covering a farm field, a power flicker, a semi struggling on an exposed highway, a town hearing thunder but seeing nothing that looks like a classic tornado scene. Then the pattern either breaks apart or connects. That is the fork in the day. If storms stay separated, the highest impact may come from large hail, isolated severe wind, and any tornadoes that can form in the right local environment. That is still dangerous, but the damage footprint may stay more scattered. If storms connect into a forward-moving complex, the hazard becomes more continuous. The leading edge starts to matter more than the individual storm core. The wind reports may line up, the outage map may begin to stretch, the emergency calls may follow the path of the gust front. The event stops looking like dots. It starts looking like a stripe, and a stripe is how infrastructure gets tested. A stripe can cross rural roads before reaching a town. It can bring down trees outside the city before power loss reaches the nursing home. It can cut electricity to traffic lights before first responders move through intersections. It can hit grain bins, then transmission poles, then cell service, then neighborhoods where people still think the main danger is a tornado warning that never came. That is the operational meaning of this day. The atmosphere is not only producing storms, it may be producing a moving load across the built environment. And that is why the first official signal matters. It is not a prediction of guaranteed disaster. It is a warning that the ingredients are aligning in a way that can change the shape of the threat. The day begins with maps and probabilities. But the risk is not abstract. It is heading toward things that have names: a highway, a feeder line, a grain elevator, a mobile home park, a hospital generator, a baseball field, a subdivision with old trees, a farm road with no shoulder, a family waiting for a siren that may never be the right signal. The dashboard shows weather. The real story is how weather becomes load, and one number on that dashboard is about to make the whole setup feel different. The number that changes the day is 75 miles per hour. According to NOAA's Storm Prediction Center, the severe storms in this setup may be capable of wind gusts greater than 75 miles per hour. That is about 120 kilometers per hour. It is not a tornado number. It does not carry the same visual image as a funnel crossing a field. It does not automatically create the same public reaction as a tornado warning on a phone. But in an operational forecast, 75 miles per hour is not a casual thunderstorm gust. It is the point where the storm stops being only weather in the sky and begins to interact with almost everything exposed on the ground. The number is not just wind. It is distance, surface area, and infrastructure being pulled into the same event. A gust at that speed does not need to remove every roof to become dangerous. It only needs to find the weak parts of ordinary life: a mature tree with heavy summer leaves, a power line crossing a road, a grain bin standing on open ground, a semi-trailer moving across a flat highway, a garage door not built for that pressure, a temporary event tent, a mobile home, a stoplight hanging over an intersection, a rural barn with one side already loosened by years of weather. That is what 75 miles per hour means outside a forecast office. It means the air itself has enough force to test objects that usually feel permanent. A person hearing that number may compare it to driving on the highway. That is understandable, but it is not the same thing. When a car moves at 75 miles per hour, the vehicle is built to cut through air. The windshield is angled. The frame is engineered. The tires are gripping pavement. The driver is inside a system designed for motion. A thunderstorm gust is different. The house is not moving through the air. The air is moving into the house, around the house, under the eaves, against the garage door, through the trees, across the roof line, and into every exposed surface at once. The force is not arriving as a smooth highway flow. It arrives with rain, turbulence, falling branches, pressure changes, and sudden shifts in direction. It can hit one side of a structure, relax for a few seconds, then hit again from a slightly different angle. That is why a single gust number can understate the experience. The forecast says 75 miles per hour. The neighborhood experiences impact, vibration, noise, debris, and failure points. To understand why this number matters, start with the official severe threshold. The National Weather Service classifies thunderstorm wind as severe when gusts reach 58 miles per hour or higher. That threshold already matters. At that level, trees can be damaged and power lines can come down. So when the forecast raises the concern towards 75 miles per hour or higher, the atmosphere is moving beyond the base definition of severe and toward a level that can create more significant damage. The difference between 58 and 75 is not just 17 miles per hour, it is a jump in force. Wind pressure does not rise in a simple straight line with wind speed. When wind speed increases, the force on objects rises faster. A gust that is somewhat faster can feel much more powerful to a tree, a roof edge, a truck trailer, or a power pole. That is why small increases near the high end matter so much. A storm does not need to double its wind speed to double the stress on the things in its path. This is where the headline number becomes a system number. At lower speeds, a thunderstorm may scatter limbs and cause temporary disruption. At higher speeds, it starts asking whether the built environment has margin. Are the trees trimmed far enough from distribution lines? Are poles already weakened by age or saturated soil? Are rural roads clear enough for emergency vehicles after branches fall? Are backup generators tested? Are cell towers ready to stay online when local power fails? Are drivers off open highways before the gust front reaches them? The number is not just 75. The number is what 75 does when it arrives at the same time as rain, lightning, darkness, traffic, aging trees, and a public trained to look first for tornadoes. That is the abnormal part. Severe thunderstorms are part of the Midwest and Plains calendar. Farmers, forecasters, utilities, and emergency managers expect spring and summer storm days. But a damaging wind setup with gusts greater than 75 miles per hour shifts the burden from isolated weather awareness to broad operational readiness. The issue is not simply that a storm can be strong. The issue is that the storm may produce a kind of force that is wide enough to touch many systems at once. A tornado can devastate a narrow path. It can destroy a home and leave the house down the road barely damaged. That is part of what makes tornado damage so haunting. It is extreme, concentrated, and violently specific. Straight-line thunderstorm wind behaves differently. It can be less intense at the peak and still more expansive in consequence. It can take down scattered trees across an entire town. It can block multiple roads instead of one. It can cut power to a broad feeder circuit. It can damage farm structures across miles of open land. It can overturn high-profile vehicles where the road is exposed. It can create hundreds of small failures that do not look catastrophic in isolation but overwhelm the ability to recover quickly. That is how a 75-mile-per-hour gust becomes more than a weather statistic. It becomes workload. 1 tree down is a public works call. 10 trees down is a route problem. 100 trees down across several communities is a recovery operation. 1 power line down is a repair. Many power lines down across a moving corridor is a grid restoration sequence. 1 blocked road is inconvenient. Multiple blocked roads near the same time can slow ambulances, utility crews, fire response, and families trying to move away from the storm. The wind does not need to win everywhere. It only needs to create enough failures close together. This is why the same number carries different meaning depending on where it lands. Over open fields, a 75-mile-per-hour gust may flatten crops, damage irrigation equipment, tear metal from outbuildings, or move unsecured machinery. In a small town, it may find old trees, overhead wires, porches, garages, church steeples, baseball dugouts, and traffic lights. Along a highway, it may hit trailers and recreational vehicles at the worst possible angle. In a suburban neighborhood, it may turn lawn furniture, trash bins, roofing material, and branches into fast-moving debris. The number is constant. The damage changes with exposure. This is why forecasts include more than a map. A wind gust forecast is a warning about a meeting between atmosphere and objects. The atmosphere brings speed. The ground supplies vulnerability. The result depends on what sits in the path. For a farm, 75 miles per hour may arrive as a choice made too late. Should equipment have been moved? Should livestock have been brought closer to shelter? Should doors on outbuildings have been secured before the line arrived? Should irrigation pivots have been parked differently? Should a grain bin, already stressed by age and weather, be checked before the first gust hits? For a driver, it arrives as a sudden change in visibility and control. Rain hits the windshield, the sky lowers, dust or spray crosses the road. The line of storms appears to be approaching from one direction, but the gust front arrives before the heaviest rain. A high-profile vehicle begins to move under the force. The driver has seconds to decide whether to continue, slow down, pull over, or search for shelter that may not exist on a rural highway. For a homeowner, it arrives as sound. The wind builds against the walls. The trees begin to lean in one direction. Then the gust pulses. A branch hits the roof. Lights flicker. A phone alarm sounds. Someone looks out the window because people want to see what is happening, even when the window is the wrong place to stand. If the storm is moving fast, the safest decision has to be made before the mind fully updates the danger. That is the gap between forecast language and lived experience. The official number is measured in miles per hour. The human experience is measured in seconds. A 75-mile-per-hour gust does not politely announce that it has crossed a threshold. It arrives as motion. It arrives as force on a garage door. It arrives as a tree limb landing on a service drop. It arrives as a transformer flash. It arrives as a crash on a wet road. It arrives as a child asking whether this is a tornado, while the adult is trying to decide whether the basement is still the right place even without a tornado warning. The answer is yes. If destructive straight-line winds are approaching, interior shelter matters. Staying away from windows matters. Getting off the road matters. Treating severe thunderstorm warnings seriously matters. The absence of a tornado warning does not mean the absence of life-threatening wind. That is one of the central failures in public perception. The word tornado activates people. The phrase severe thunderstorm sometimes does not. It can sound ordinary, especially in places that experience many storms every year. But when the forecast includes gusts greater than 75 miles per hour, ordinary is the wrong frame. That number belongs to a class of thunderstorm wind that can damage structures, knock down trees, and interrupt power at a scale that may outlast the storm itself. The event outside may last minutes. The recovery can last days. That is another reason the headline number matters. The wind is short-lived at any one point, but the damage footprint can stretch across many points. A single town may experience only a brief period of extreme wind, but if the storm complex keeps moving, the region experiences a sequence of brief impacts that add up to a long event. Each community sees its own few minutes. The emergency system sees the whole corridor. That is why the number must be interpreted not only in time, but in space. 75 miles per hour over one field is dangerous. 75 miles per hour, repeating through county after county, becomes a different category of concern. It begins to resemble a moving stress test. The atmosphere pushes, the built environment answers. Some parts hold, some parts fail. The map after the storm is not only a record of wind, it is a record of where the system had margin and where it did not. This is the part of the forecast that does not fit easily into a simple headline. People ask, will there be tornadoes? Forecasters also ask, will storms merge? Because once storms merge, the wind number changes meaning. It is no longer only a peak gust. It becomes a signal of how much force the line may carry forward. It becomes a warning that the hazard can outrun the mental picture people have of severe weather. It becomes the difference between watching one cell and preparing for a corridor. That is why the 75 mile per hour number sits at the center of this setup. It is strong enough to damage. It is broad enough, if organized into a line, to disrupt. And it is familiar enough in wording that some people may underestimate it until it is too late. The number is not just wind, it is the road being tested while people are still driving. It is the power line being tested while the hospital is still drawing electricity. It is the tree being tested while a family is still watching from the window. It is the farm being tested while the growing season is still underway. It is the warning system being tested while the public is still waiting for the word tornado. And that is why the headline number, as dangerous as it is still not the full story. The visible number is 75 miles per hour, but the hidden number is how long that force lasts and how far it can travel before the system finally breaks apart. The visible number is 75 miles per hour, but the hidden number is distance, and behind distance there is another hidden number, duration. A single violent gust can damage a building, snap a tree, or overturn a trailer, but a wind swath becomes dangerous in a different way. It repeats the stress. It pushes across one road, then the next road, then the next town, then the next feeder line, then the next county. At each point, the wind may last only minutes. Across the region, the event can last for hours. That is the trap. The public often looks for the peak. Forecasters have to look for the path. The visible number makes the headline. The hidden number writes the damage. According to the National Weather Service, a derecho is not simply a severe thunderstorm with strong wind. It is a widespread, long-lived windstorm associated with a band of rapidly moving showers or thunderstorms. For a storm system to meet the classic definition, the wind damage swath must extend more than about 240 miles, and wind gusts of at least 58 miles per hour must occur along most of that path. That definition changes how the setup has to be read. A possible derecho is not proven by one extreme gust. It is not proven by one town losing trees. It is not proven by one radar image that looks dramatic for a few minutes. It is proven by continuity. The storm has to hold together. The wind has to keep producing damage. The path has to stretch far enough that the event becomes regional rather than local. That is why the official signal matters but does not finish the story. The Storm Prediction Center is not saying the word derecho as a guarantee. It is pointing to the possibility of storms growing upscale into a southeast moving mesoscale convective system capable of damaging wind swaths. That language is careful. It says the atmosphere may support a larger wind-producing system. It does not pretend the damage path is already known, but even without a confirmed derecho, the hidden number is already important. How far can the line travel? How long can the wind remain organized? How many communities can be touched before the system weakens? These questions matter more than they sound. A tornado setup makes people look for rotation. A wind swath setup makes forecasters look for persistence. The danger is not only whether one storm can become violent, the danger is whether many storms can become one moving machine. The headline is wind speed. The real story is wind continuity. A severe thunderstorm warning may last for one county at a time. A storm complex does not care about county lines. It enters one warning polygon, exits into another, and forces the system to keep handing off danger while the public tries to understand what is happening. One emergency manager is watching the western edge. Another is preparing downstream. A third is already receiving reports of trees down, wires down, and roads blocked. By the time people in the next town hear thunder, the first town may already be calling for help. That is what duration means operationally, not just how long the wind blows over one house, how long the system keeps creating new places that need help. If a storm complex holds together for several hours, every minute becomes a transfer of load. The leading edge pushes forward, rain-cooled air spreads outward, new storms build along the gust front. The system may bow. The strongest wind may surge through one segment, then another. On radar, it may look like a line. On the ground, it feels like a sequence of impacts that keep arriving faster than recovery can begin. This is where a damaging wind event starts to separate itself from ordinary severe weather. Ordinary severe storms can be dangerous, but the impacts are often scattered. A hail core here, a tree down there, a brief power outage in one neighborhood, a report of wind damage 10 miles away. The system absorbs it. A wind swath is different. It aligns damage. Alignment is what overwhelms response. When damage lines up across space, resources have to move in the same direction as the storm. Utility crews may not be able to start full restoration until the line has passed and lightning has cleared. Road crews may find that the roads they need are blocked by the same wind that caused the outage. Emergency medical services may face calls from multiple places at once. Dispatchers may be trying to separate urgent life safety calls from hundreds of reports that all sound similar. Tree down, wire down, road blocked, roof damage, power out, transformer sparking, alarm going off, vehicle hit by debris. None of those reports has to be historic alone. Together, they become the event. That is why the hidden number cannot be treated as technical detail. A damage corridor of 50 miles is a local emergency. A damage corridor of 200 miles is a regional operation. A damage corridor beyond 240 miles begins to enter Derecho territory if the other criteria are met. The difference is not only meteorological, it is administrative. It changes who gets called, how mutual aid is staged, how many crews are needed, how long restoration may take, and how many communities are competing for the same repair capacity. The wind is measured by instruments. The damage is measured by cues. How many roads wait to be cleared? How many transformers wait to be replaced? How many customers wait for power? How many families wait for information? How many farms wait to learn whether the crop survived? That is the hidden number. It is the number of systems touched before the storm exits the region. The reason Derecho-type wind is so easy to underestimate is that it does not always produce one iconic image. A tornado can leave a photograph that explains itself instantly. A slab where a house used to be, a narrow path through trees, a school gym torn apart while nearby blocks remain recognizable. The violence is visible because it is concentrated. A wind swath may leave a different kind of evidence, not one image, but thousands. A county road covered by branches, a power pole leaning at the edge of a field, a grain bin crumpled inward, a stoplight dark at an intersection, a nursing home running on generator power, a gas station unable to pump fuel, a family throwing out food from a refrigerator after the outage lasts too long, a farmer walking a field where plants are shredded in one direction, a town where every street has some damage, but no single street looks like the entire disaster. This is how broad wind hides inside ordinary language. People say, it was just a severe thunderstorm, but the system does not experience it as just anything. The grid experiences it as faults across a feeder network. Roads experience it as blocked access. Hospitals experience it as generator checks and delayed arrivals. Farms experience it as physical damage during a narrow growing season. Insurance systems experience it as thousands of claims. Families experience it as heat, darkness, spoiled medicine, broken windows, and the uncomfortable realization that the siren they were waiting for was never the only warning that mattered. The map shows the storm, the hidden number shows the reach. This is why coverage matters as much as intensity. A single 75-mile-per-hour gust can create a severe report. A corridor of severe gusts can create a regional stress test. If the strongest wind is narrow and brief, the system may recover quickly. If the wind is repeated across many towns, recovery becomes staggered. The first community may need crews while the storm is still damaging the next. Mutual aid may be requested before the full extent is known. Damage assessment may lag behind outage maps because roads are blocked and night may arrive. And if the storms move after dark, the hidden number becomes even more dangerous. Night changes the public response. During the day, people can see the sky lowering. They can see trees moving. They can see the shelf cloud. They can see debris crossing the road. At night, the warning arrives as sound, vibration, lightning flashes, and a phone alert. The wind may be at the door before the person has built the correct mental picture. They may still be thinking tornado or no tornado while the line itself is already the hazard. That is why the wording matters. Destructive thunderstorm winds are not a lesser warning just because they are not a tornado. A storm complex capable of widespread damaging wind can be life-threatening in places where people stay near windows, remain in vehicles, or dismiss the warning because the funnel they imagine never appears. The body does not care whether the wind rotated. A falling tree does not care whether the warning said tornado. A power line does not care whether the storm was photogenic. A high-profile vehicle does not care whether the damage path will later be classified as a derecho. The load arrives either way. This is the central shift in the story. The public question is, will there be tornadoes? The system question is, how far will the wind hold together? That second question is colder. It is less dramatic. It is also more useful for understanding why the setup deserves attention. Because once storms begin to organize, the risk is no longer confined to the place where the first severe cell formed. It can become downstream, it can become cumulative, it can become a moving line of decisions. A school district decides whether to hold evening activities, a trucking dispatcher decides whether to route around the line, a hospital facilities manager checks fuel for backup power. A family decides whether to park under trees or move the car. A farmer decides whether there is still time to secure equipment. A county emergency manager decides whether to prepare for warnings that may come in waves. Every one of those decisions depends not only on how strong the wind gets, but on whether the wind threat expands. That is why duration changes risk. A short burst gives little time, but a limited footprint. A sustained, organized line gives more people exposure. Even if each person only experiences a short hit, the storm becomes a moving clock. People downstream are not safe just because the first damage happened far away. They are next in a sequence that may still be strengthening, weakening, bending, splitting, or accelerating. The hidden number is not static. It evolves as the storm evolves. A line that looks ragged at first can consolidate. A cluster that looks disorganized can become a bowing segment. A cold pool can deepen. The rear inflow can strengthen. The strongest winds can descend from above the ground into the surface layer. The gust front can surge ahead. The warning language can sharpen. Reports can begin to line up. And once the reports line up, the forecast stops being only a forecast. It becomes evidence in motion. That is the moment when a severe weather day becomes an infrastructure story. The damage is no longer just where the storm is. It is where the storm has been and where it is still going. The system has to respond backward and forward at the same time. Crews are needed behind the line. Warnings are needed ahead of it. Roads must be cleared after it. People must shelter before it. The same storm creates past damage and future risk at the same time. That is why the hidden number writes the damage. Not because the peak gust is unimportant. It is important. 75 miles per hour is a serious number. But the hidden number decides whether that serious number becomes isolated disruption or a regional problem. It decides whether damage stays as dots or becomes a stripe. It decides whether the event is remembered as a few severe reports or as a wind corridor that exposed weak points across the map. The atmosphere does not have to produce the strongest tornado to create the larger operational burden. It only has to organize the wind. This is not just a tornado setup. This is a wind swath infrastructure test. And to understand how a line of storms can turn instability into that kind of moving force, the story has to leave the ground for a moment. The next clue is above the plains, inside the storm structure itself. The mechanism begins above the plains, but it does not stay there. It begins in air that has been prepared before most people see the first dark cloud. Near the ground, warm and humid air is waiting. Above it, Winds are moving at different speeds and sometimes from slightly different directions. Along a boundary, air is being lifted. That boundary may be a front. It may be an outflow line left behind by earlier storms. It may be a subtle zone where moisture, temperature, and wind shift just enough to give the atmosphere a focus. This is where a thunderstorm begins to turn fuel into motion. Warm air rises, moisture condenses, heat is released inside the storm. The updraft strengthens. Rain and hail begin to form. At first, this can look like the familiar severe weather story. One storm grows taller than the others. Another storm forms nearby. A forecaster watches to see whether any of them rotate. A person on the ground looks west and sees a tower rising against the sky. But the danger does not only depend on one storm, it depends on what the storms do to each other. In a tornado setup, the public often imagines a single rotating supercell. That mental picture is not wrong. Supercells can produce large hail, damaging wind, and tornadoes. They are among the most dangerous storms on the planet. But the mechanism that can dominate a day like this is different. It is not only about one storm spinning harder. It is about storms connecting. When storms connect, the atmosphere starts building a larger machine. The name for that machine is a mesoscale convective system. Mesoscale means it is larger than one storm, but smaller than a continent-wide weather system. Convective means it is built from rising air, thunderstorms, rain, hail, lightning, and downdrafts. System means the storms are no longer acting as separate towers. They begin to share structure. They begin to reinforce one another. They begin to move as a group. That is when the story changes. The mechanism begins above the boundary. It moves through the storm, then it reaches the surface as wind. Inside each storm, rain and hail are falling through the air. Some of that falling precipitation drags air downward. Some of the air is cooled by evaporation as rain falls through drier layers below the cloud base. Cooler air is denser. Denser air wants to sink. As it sinks, it accelerates. When it reaches the ground, it cannot keep going down. It spreads outward. That spreading air is the gust front. To a person standing outside, the gust front may arrive before the heaviest rain. It may feel like a sudden wall of wind. Leaves turn their pale undersides. Dust lifts from a gravel road. The temperature can drop quickly. The sky may look green or black or simply heavy. The wind shifts. The storm has reached the surface before the storm core has fully arrived. But in a growing storm complex, that gust front is not just an edge, it is an engine. As the cold air spreads forward along the ground, it lifts warm, humid air ahead of it. That new warm air rises. New storms form along the leading edge. Those storms rain into the system. More rain-cooled air sinks. More cold air spreads. The gust front keeps pushing. The line keeps feeding itself. This is how separate storms become a forward-moving system. The cold pool is the key. A cold pool is the area of rain-cooled air near the ground beneath and behind the storms. It can feel like relief after a hot, humid day. But inside a severe weather system, the cold pool is not just cooler air. It is mass. It is pressure. It is a shallow river of denser air spreading outward beneath the storm. If the cold pool is strong enough, it can surge forward and force more warm air upward along its front edge. A strong cold pool can organize the storm line. Too weak, and the storms may struggle to maintain a coherent wind threat. Too strong, and the cold air can outrun the updrafts, cutting off the storm from its fuel. But when the cold pool and the winds above it are balanced, the system can become efficient. The leading edge keeps lifting warm air. The storm keeps producing rain and downdrafts. The wind field keeps pushing. This is the balance forecasters watch. The atmosphere does not need to produce one perfect tornado to become dangerous. It only needs to organize the downward and forward motion of air. That is the first hidden mechanism. Air rises to build the storm, air sinks to build the wind. Then comes the second mechanism, the rear inflow jet. The phrase sounds technical, but the idea can be understood visually. Imagine a line of storms moving forward. Behind that line, air begins to accelerate into the storm system from the rear. It flows toward the front of the line, sometimes descending as it moves. If that air reaches lower levels and connects with the surface, it can increase the wind rushing out along the leading edge. It is like a push from behind. The storm line is already moving. The cold pool is already spreading. Then a current of faster air enters the backside of the system and helps drive the leading edge forward. On radar, this can help produce a bowing shape, where part of the line bulges outward. That bowed segment is often where the most intense straight-line winds occur. A bow echo is not just a shape on radar. It is a signal that the storm system may be accelerating wind toward the ground. The middle of the bow surges ahead. The ends can curve back. Embedded circulations may form along the line. Some of those circulations can produce brief tornadoes. That matters because a wind-dominated storm complex does not mean the tornado threat disappears. It means tornadoes, if they occur, may be embedded inside a larger damaging wind event. They may be harder to see. They may happen quickly. They may be wrapped in rain. But the larger structure is still the line. The line is the machine. This is not just a tornado setup. This is a wind swath infrastructure test. The mechanism begins in the atmosphere, but it becomes real when momentum reaches the ground. Momentum is simply moving air carrying force. Winds above the ground may be stronger than the winds at the surface. In a storm, downdrafts can bring some of that stronger air downward. If the storm structure allows it, wind that was moving faster aloft can be transported toward the surface. When that happens along a line, the strongest gusts can spread across a wide area. The damaging wind at the ground is not random. It is connected to storm structure. It is connected to the cold pool. It is connected to the rear inflow. It is connected to how the line bows. It is connected to whether the storm can keep feeding on warm, humid air ahead of it. This is why forecasters do not only look at radar color, they look at motion, they look at velocity data, they look at storm reports, they look at how new cells form along the leading edge. They look at whether the line is becoming more continuous. They look for notches, surges, bows, and places where the wind field appears to be tightening. Radar is not just showing rain, it is showing architecture, and the architecture can either collapse or strengthen. If the storm line outruns its fuel, it may weaken. If the cold pool becomes too dominant, the updrafts may be undercut. If the environment ahead becomes more stable, the line may lose intensity. If wind shear is not supportive, the system may become messy and less organized. But if the environment ahead remains warm and moist, if the wind profile supports organization, if the cold pool remains strong but not destructive to the updrafts, and if the rear inflow strengthens, the line can keep going. That is the operational concern, not one storm, a system that keeps going. Once that system is moving, the mechanism travels downward through ordinary objects. First, it reaches the trees. Trees are living structures, not engineered towers. In summer, they carry leaves that increase the surface area exposed to wind. The canopy catches air like a sail. Branches flex, trunks bend, roots hold against the pull. If the soil is wet from earlier rain, the root system may have less grip. If the tree is old, hollow, diseased, or already stressed, the margin is smaller. The storm does not need to destroy the tree completely. It only needs to break the limb that crosses the line. Then, the mechanism reaches the power system. A branch falls, a line slaps, a transformer sparks, a fuse operates, a feeder circuit trips. The power goes out in houses that were never touched directly by the strongest part of the wind. People inside those houses may say the storm was not that bad where they were. The grid says otherwise. The grid records the path of failure, not just the peak gust at one address. Then the mechanism reaches the road. Rain reduces visibility. Wind pushes vehicles sideways. Branches fall into lanes. Traffic lights lose power. Emergency vehicles have to navigate around debris. A driver who kept moving because there was no tornado warning may suddenly face a tree across the road, water over the pavement, or a truck ahead fighting the crosswind. The air has become a transportation problem. Then it reaches the farm. Open ground offers fewer wind breaks. Grain bins, machine sheds, irrigation systems, livestock shelters, and equipment yards become exposed surfaces. A barn door that was slightly open becomes a failure point. Metal panels peel. A bin buckles. Hail and wind combine on fields already vulnerable in the growing season. A storm that lasted minutes can affect income for months. The air has become an agricultural problem. Then it reaches the hospital. The hospital may never take a direct hit from a tornado. It may never lose a wall. But if power fails nearby, if roads are blocked, if injuries come in from crashes or falling trees, if oxygen-dependent patients at home lose electricity, if nursing homes switch to backup generators, the hospital becomes part of the storm system. The mechanism that began as unstable air has entered triage, staffing, transportation, and backup power. The air has become a medical problem. That is how the mechanism moves. From the atmosphere into the storm. From the storm into the gust front. from the gust front into trees, from trees into wires, from wires into homes, from homes into bodies, from bodies into emergency systems. By the time the damage becomes visible, the system is already carrying load. This is why a damaging wind setup can feel less dramatic at first, but become more consequential over time. The first stage is meteorological, the second stage is mechanical, the third stage is human, the fourth stage is institutional. Every stage depends on the one before it, and every stage can magnify small failures. A loose branch becomes a power outage. A power outage becomes a medical problem. A blocked road becomes a delayed response. A delayed response becomes a worse outcome. The atmosphere does not have to know any of this. It simply moves air. The built environment supplies the chain. This is also why the distinction between tornado wind and straight-line wind can be misleading for people outside the science. Meteorologically, the distinction matters. Tornado winds rotate violently around a small circulation. Straight-line winds spread outward from thunderstorm downdrafts and stormline dynamics. The damage patterns can differ, the warning process can differ. The post-storm survey can identify different causes, but to the person under the tree, the distinction is not the first problem. The first problem is force. A tree falling on a bedroom does not become harmless because the wind was straight line. A semi pushed across a lane is not safer because the storm did not produce a funnel. A power line on the ground is not less energized because the damage came from a bow echo. The physics of impact reaches the human before the classification does. The classification matters later. Shelter matters now. That is the point where understanding becomes action. If a storm complex is moving in with destructive wind potential, the safest place is not by a window watching for a tornado. It is inside, away from glass, preferably in a sturdy building, in an interior room, on the lowest level available. Cars and mobile homes are especially vulnerable. Open roads, campgrounds, ball fields, and temporary structures can become dangerous quickly. The mechanism is invisible until it touches something. The Derecho is unmistakable. A shelterson cloud may mark the leading edge. Lightning may pulse inside the line. The wind may arrive with a roar that some people mistake for a tornado. Rain may follow so hard that the outside world disappears. The lights may flicker before the strongest gust. A garage door may flex inward. The house may make sounds the occupants have never heard before. That is not the storm being dramatic. That is pressure and motion finding the building. And if the storm line is part of a larger wind swath, the same scene may repeat across miles. One family hears the roar at one time. 10 minutes later, another family hears it. Then another town. Then another road. Then another substation. Each experience is local. The mechanism is regional. That is why the wind swath matters. A tornado warning can focus fear in a tight area. A destructive wind line spreads responsibility across every place in its path. It demands action from people who may not feel singled out. It requires them to understand that a severe thunderstorm warning can carry life-threatening consequences. It asks them to respond to the line before the line proves itself at their address. The storm system does not wait for belief. It uses the physics already in place. Warm air rises, rain-cooled air falls, cold air spreads. The gust front lifts new fuel. The line organizes. Rear inflow pushes. The bow surges. Momentum descends. The surface takes the load. That sequence is the hidden machinery behind the official number. 75 miles per hour is the output. The mechanism is what decides whether that output appears briefly in one place or repeats across a corridor. It decides whether storms remain scattered or become a moving wind field. It decides whether the day is remembered mainly for isolated reports or for a long stripe of outages, blocked roads, and damaged structures. And the most unsettling part is that the mechanism can become clear only after it has already started. Early in the day, forecasters can see the ingredients. They can identify the risk. They can warn that storms may grow upscale. But the exact moment when separate storms become one organized wind producer is often watched in real time. The radar begins to show the connection. The reports begin to line up. The warning language begins to sharpen. The event begins to reveal what the atmosphere chose to build. That is why the official signal matters before the line exists. It gives people time to understand the mechanism before the mechanism reaches them. Because once it does, the story is no longer about air moving on a map. It is about the route that air takes through a life. The next clue is not in the storm structure anymore. It is inside a room, where one family hears the wind arrive before they understand what kind of storm they are in. The mechanism is no longer above the plains. Now it is outside a house. Imagine a family on the edge of a small Midwest town, in a place where the main road runs past soybean fields. The power lines are still overhead, and the trees around the neighborhood have been growing for decades. The house is not unusual. It has a basement, a garage, a refrigerator full of food, a phone charger in the kitchen, a sump pump in the lowest corner, and one large maple tree standing between the yard and the distribution line behind it. Inside, the day has not yet become a disaster. It is still Tuesday. A parent is checking the phone between errands. A teenager is asking whether practice will be cancelled. An older relative in the back room has a small medical device that depends on electricity. The television is on low. The sky outside is humid and restless, but not yet violent. The family has heard severe weather before. They know the word tornado. They know the siren. They know the basement, but they do not yet understand that the storm may arrive as a line. That difference matters. The body does not experience severe weather as a probability. It experiences it as sound, pressure, darkness, heat, fear, and decisions made too quickly. The first part of the mechanism enters through information: a phone alert, a weather app notification, a local meteorologist showing a line of storms still west of town. The wording says severe thunderstorm warning. The hazard says destructive wind. Somewhere in the text, the wind number is serious. But the household hears the message through habit. Is there a tornado warning? That is the question they ask first. The answer, at that moment, may be no. And that is where the risk begins to move closer. The parent looks out the window. The sky is lower now. The trees are beginning to move, but not violently yet. Rain has not started. There is no visible funnel. The family has seen thunderstorms before, and many of them passed with noise, rain, and nothing more than branches in the street. So the mind searches for a familiar category. Thunderstorm, not tornado, may be fine, but the atmosphere does not care which word feels more urgent. The gust front reaches the town before the heaviest rain. The air changes first. It comes across the fields and into the streets. It finds the open spaces, the tree lines, the roofs, the power poles, the stop signs, the garage doors, and the loose objects people meant to bring inside earlier. The wind enters the neighborhood as pressure. The maple tree outside the house begins to lean. Not a gentle sway, a full body movement. Leaves flatten in one direction. Smaller branches turn and twist. The canopy catches the wind like a sail. The roots hold at first. The trunk bends. The weakest branch takes the load. Inside the house, the family hears it before they understand it. A low push against the walls. A hard slap of rain on one side. A trash bin rolling across the driveway. Then the phone sounds again. The teenager walks toward the window because that is what people do when the outside suddenly becomes louder. The parent tells them to move back. The older relative asks whether it is a tornado. Nobody can answer with confidence because the sound is close enough to confuse the category. The forecast shows weather. The body receives load. The first physical pathway is through attention. Wind changes what people look at. It pulls them toward windows. It makes them check trees, roofs, cars, and neighbors. But a window is also one of the wrong places to be. In destructive straight-line wind, glass can break from debris or pressure. A branch can hit the side of the house. Loose metal can travel faster than a person expects. The safest action is simple. Move inside, move low, stay away from windows. But simple actions are not always easy in the moment. The mind still wants proof. It wants to see the thing that justifies shelter. It wants a funnel, because a funnel would settle the argument. Without that image, some people hesitate. That hesitation is part of the human pathway. Then the lights flicker. A flicker changes the room. It turns the storm from something outside into something inside. The television cuts out for 1 second. The refrigerator hum stops and restarts. The medical device in the back room beeps. The older relative calls from the hallway. The parent realizes the phone battery is at 23%. The storm has now entered the electrical system of the house. Not because the house has been struck, not because the strongest wind is directly over the roof, but because somewhere nearby, the wind has found a line, a branch, a pole, a transformer, or a connection that could not hold the load. The maple tree drops a limb. It does not destroy the house. It does not create an image that would lead a national broadcast. It falls across the service drop and pulls it hard enough to make the lights go out. At the same time, another limb 2 streets away blocks part of the road. A third tree down the feeder line trips a circuit. The outage map begins to change. Inside the house, everything becomes immediate. The basement is still the safest place from wind, but the sump pump depends on power. If rain keeps falling hard, water could begin to rise later. The refrigerator is now a timer. Medication that needs cooling is now part of the storm. The older relative's device has battery backup, but nobody knows how many hours it will last if the outage spreads. The cell signal is still there, but weaker. The teenager wants to text friends. The parent wants to preserve battery. The storm has created a family argument without ever entering the front door. This is how a wind swath becomes personal. It does not only break things, it changes decisions. Should they go to the basement now? Should they check the breaker? Should they open the garage by hand? Should they call a neighbor? Should they unplug appliances? Should they move the older relative downstairs? Should they go outside to see the damage? The answer to the last one is no, but curiosity is powerful. After a loud impact, people want to know what happened. They want to see whether the car is hit, whether the tree is down, whether the roof is damaged. The storm uses that instinct against them. The first lull may not be the end. A bowing line can deliver pulses of wind. Rain can hide falling limbs. Lightning can continue. Power lines can be on the ground and still energized. The danger is not only the first gust. It is the minutes after it, when people believe the worst has passed. The body receives stress before injury ever occurs. The heart rate rises. Breathing becomes shallow. The older relative moves slowly down the hallway because rushing is not possible. The parent has to decide whether to help them to the basement or keep them in the most interior room on the main floor. The teenager is scared, but trying not to show it. The house creaks. The wind pushes again. Outside, the line is moving. Inside, time compresses. This is where the storm crosses from weather into health. A person with limited mobility cannot shelter as quickly as a healthy adult. A person using oxygen cannot treat a power outage as inconvenience. A person who depends on refrigerated medicine cannot wait days without planning. A person in a mobile home has a different risk profile from a person in a basement. A person driving home from work is exposed in a way the family inside is not. The same warning reaches different bodies differently. That is why the phrase "people are affected" is not enough. A body with asthma hears wildfire smoke differently. A body without air conditioning experiences nighttime heat differently. A body in a car experiences floodwater differently. And in this storm, a body in a house with overhead power, old trees, and medical dependence experiences wind differently. The storm is not equal when it reaches the ground. Exposure decides who carries more of the load. A few blocks away, someone is still driving. They left work early because they wanted to beat the storm. The line moved faster than expected. Rain now falls sideways across the windshield. The wipers are at full speed and still not enough. The driver slows, but the shoulder is narrow and trees line both sides of the road. A branch hits the hood. A traffic light ahead is dark. Cars treat the intersection differently because power loss has made the rules less visible. The wind has entered transportation. At the same time, a volunteer firefighter hears the call tone. Trees down, wires down, possible injury, road blocked. The storm is still active. The responder has to wait for safe movement, or move slowly through an environment where the hazard is not finished. The person who needs help may be only a few miles away. The route may be longer now because one road is blocked and another has a line down. The wind has entered emergency response. Back inside the house, the family has moved away from windows. The older relative is seated in the interior hallway. The teenager is holding the phone near the floor trying to find signal. The parent is listening for the difference between wind and impact. A siren may sound, or it may not. The absence of a siren does not reduce the force outside. That is one of the hardest lessons of a wind-dominated severe weather day. The warning system is not only a sound in the air, it is also text, radar, official wording, local meteorologists, and the judgment to treat destructive wind as a real threat. If people wait for the most dramatic signal, they may wait too long. A tornado warning says take shelter because rotating danger may be approaching. A destructive severe thunderstorm warning should also change behavior. The body cannot wait for the classification. The body needs the safest room before the branch reaches the window. Then the strongest gust arrives. The house does not lift, the roof does not vanish. This is not the image people associate with the worst storm they can imagine. But the garage door flexes inward. The old maple loses another limb. A transformer flashes blue down the block. The sound is so loud that the teenager starts crying. The older relative asks whether the device is still running on battery. The parent says yes, but checks twice. The storm has not destroyed the family. It has reduced their margin. That is the quieter human consequence. Margin is the space between stress and failure. A healthy person with a charged phone, a sturdy basement, no medical dependence, and a working car has more margin. A person alone in a mobile home with poor cell service, under trees, with medication needs, has less. A wind swath does not distribute its burden evenly. It finds the margins that were already thin. This is why infrastructure and human vulnerability cannot be separated. The power line is outside, but the medical device is inside. The road is outside, but the ambulance delay is inside the body. The tree is outside, but the bedroom is below it. The warning polygon is on a map, but the decision happens in a hallway. The atmosphere becomes human through these pathways. A gust front does not know about age, disability, income, language, housing quality, or access to transportation. But once it reaches the ground, all of those things begin to matter. A family with a basement has one set of choices. A family in a manufactured home has another. A person who can take shelter quickly has one timeline. A person who needs assistance has another. A person who understands the warning language has one advantage. A person who hears severe thunderstorm and thinks ordinary rain may lose that advantage. The storm tests more than structures. It tests interpretation. When the wind finally begins to ease, the family does what many families do. They want to look. The parent opens the front door a few inches. The air smells like rain, leaves, and something electrical. Branches cover the yard. The street is dark. A neighbor's car alarm is going off. Somewhere, a generator starts. Somewhere else, a dog is barking. There is no clear image of catastrophe, but nothing feels normal. The phone has only one bar. The outage is not just at this house. That discovery changes the next several hours. If power is out across town, restoration will take longer. If roads are blocked, help will move slower. If the storm line is still hitting communities downstream, crews may not be free yet. If the medical device battery runs low, the family may need to go somewhere with power, but the route may not be clear. The gas station may not pump. The traffic lights may be dark. The hospital may be receiving calls from other households facing the same problem. The storm has passed the house. The system load has not. This is the point where a weather event becomes recovery. The family is safe for the moment, but they are now dependent on layers of infrastructure they rarely think about. Electric distribution, road clearance, cell service, emergency dispatch, fuel supply, backup generators, pharmacy access, refrigeration, neighbor networks, public information. Each layer was quiet before the wind. Now each layer matters. That is why the human pathway has to be followed all the way through. The story does not end when the gust front moves east. For the atmosphere, the event has moved on. For the family, the event remains in the dark house. The beeping device, the blocked road, the wet basement corner, the food warming in the refrigerator, and the uncertainty about when power will return. The line outside becomes a question inside. How long can this household function without the systems it assumed would be there? And that question points to the next part of the story, because the weak point is not the whole town. It is not even the whole grid. The weak point is smaller than most people think. It is the neighborhood distribution line running behind the trees. The weak point is not the whole grid. The weak point is the neighborhood distribution line running behind the trees. It is easy to picture infrastructure as something enormous: a power plant, a transmission corridor, a control room, a map of lines crossing the country. But for the family in the dark house, the critical system is much smaller. It is the pole behind the yard, the transformer on the street, the fuse that opens when a fault occurs, the service drop running into the home, the tree limb hanging over a line that most people stop noticing after they have lived beside it long enough. That is where a wind swath finds the system. The larger grid may still be producing electricity, the power plant may be operating, the transmission system may be intact. But none of that matters to the refrigerator, the sump pump, the oxygen machine, the traffic light, or the phone charger if the final local connection fails. The weak point is not the whole system. The weak point is the last mile. A neighborhood distribution line is built to do a quiet job. It takes electricity from the broader system and delivers it into daily life. It runs down streets and alleys, across yards, behind businesses, past schools, near nursing homes, beside gas stations, and over the roads that emergency vehicles may need after the storm. It is familiar enough to disappear. People drive under it. Children wait for buses near it. Trees grow around it. Birds sit on it. Leaves hide it in summer. Then the wind arrives. At 75 miles per hour, the line itself may not be the first thing to fail. The tree may fail first. That distinction matters. Much of the damage in a severe wind event is not wind directly snapping every piece of infrastructure. It is wind moving one object into another, a branch into a wire, a tree into a pole, a roof panel into a transformer, a loose sign into a road, a falling limb into a parked car, a garage door inward until pressure finds the structure behind it. The atmosphere does not only attack the grid, it recruits the landscape. Trees are often the first recruited objects. In summer, they are heavy with leaves. A leafed-out canopy catches wind better than a bare winter branch. After rain, the soil may be softer. Roots may have less grip. Old trees may have decay inside the trunk that nobody sees from the sidewalk. A limb that looked healthy from below may have been weakening for years. The storm only has to find the part already near failure. When that limb falls on a distribution line, the failure moves from biological to electrical. A tree becomes an outage. A branch becomes a circuit problem. A road hazard becomes a utility dispatch. The damage is no longer only in the yard. It has entered the network. That is why a single weak point can spread consequence beyond the address where it failed. One fallen limb can trip a section of line serving many homes. One damaged transformer can darken a block. One broken pole can delay restoration until crews can safely access the site, remove debris, isolate the line, replace hardware, and re-energize the circuit. One live wire on the ground can close a road. One closed road can slow an ambulance. One delayed ambulance can turn a weather problem into a health outcome. The wind begins outside. The consequence moves through systems. A distribution line normally works through layers of protection. When something goes wrong, equipment is supposed to isolate the fault. A fuse may blow. A recloser may interrupt power and attempt to restore it if the fault clears. Crews may identify the damaged section and reroute power where possible. This is not a fragile system in the sense that it fails at the first inconvenience. It is engineered with procedures, devices, and crews who know how to restore service. But a wind swath changes the scale. The system is designed to handle faults. It is stressed when many faults happen close together. One transformer problem can be handled. A few branches down can be handled. A pocket of outages can be handled. But when a bowing storm complex lays down damage across a long corridor, the problem is no longer one repair. It is triage. Crews must decide which outages affect the most people, which lines are dangerous, which facilities are critical, which roads are reachable, and which repairs must wait, because lightning, wind, flooding, or debris still make the area unsafe. The storm does not only create damage, it creates ordering problems. What gets fixed first? Who waits? Which road is cleared? Which feeder is restored? Which nursing home needs generator support? Which gas station can pump fuel? Which cell tower has backup power? Which traffic lights stay dark through the evening commute? The weak point is small, but the consequences are layered. Start with the line behind the trees. When it fails, the first visible effect is darkness. Lights go out. The television stops. The air conditioner shuts down. The refrigerator becomes silent. The sump pump waits for either backup power or rising water. Garage doors may not open unless someone knows how to release them manually. Medical devices switch to batteries. Phones become lifelines and clocks at the same time. But a blackout is not one condition. It is many conditions depending on who is inside. For a healthy adult in a sturdy house, a few hours without power may be uncomfortable. For a person who relies on electrically powered medical equipment, it can be urgent. For a nursing home, it becomes a facility operation. For a family with refrigerated medicine, it becomes a time-sensitive problem. For a person without a vehicle, it becomes isolation. For a person whose phone is almost dead, it becomes information loss. The same outage enters different lives at different severity. That is why the distribution line is not only an electrical component, it is a social component. It decides whether the warning continues to reach people after the first alert. It decides whether a household can call for help. It decides whether a pharmacy can remain open. It decides whether a gas station can pump fuel. It decides whether a traffic signal keeps order at an intersection where drivers are already stressed by rain, debris, and darkness. A line behind trees can become a transportation problem. When the power goes out, traffic lights fail. Some intersections become four-way stops. Others become confusion. Rain reduces visibility. Branches may cover lanes. Drivers may be watching the sky instead of the road. A semi may be trying to leave an exposed highway. A parent may be rushing home. A responder may be trying to reach a blocked street. The wind event is over at that intersection. But the risk remains because the systems that organize movement have been interrupted. Then the same line becomes a communications problem. Cell towers often have backup power, but backup is not infinite. If commercial power fails across a wider area, batteries and generators become part of the emergency timeline. A household with poor signal may have trouble receiving updated warnings. A person may not know whether another storm is coming. A county alert may be issued, but the phone in the hallway may be dead or searching for service. The storm can make people less informed exactly when they need information most. Then it becomes a water problem. In many homes, especially those with basements, a sump pump is not dramatic equipment. It sits unnoticed until rain and groundwater make it important. If a damaging wind line arrives with heavy rain and the power fails, the pump may stop at the moment it is needed. A basement that was shelter from wind can become a water concern later. The wind did not flood the basement by itself. It removed the electrical support that helped manage the water. The hazard compounds: wind into line, line into outage into pump failure into water damage into cost, cleanup, mold, insurance, and displacement. The chain is not spectacular at first. That is why it is dangerous. Then the weak point reaches food. A refrigerator is a small, cold storage system inside a house. A grocery store is a larger one. A restaurant has freezers. A pharmacy may have refrigerated products. A farm may have equipment and storage needs. If power is restored quickly, the disruption may stay minor. If the outage lasts longer, the clock begins to matter. Food safety, medicine storage, fuel availability, and local business losses all start counting time. A wind gust lasts seconds. The outage clock can run for days. That is the system mismatch. The atmosphere delivers a short load. The infrastructure produces a long recovery. This is why the map after the storm often looks different from the radar during the storm. The radar line moves on, the warning expires, the sky may clear, sunset may even look calm behind the system. But the outage map remains, the blocked roads remain, the crews remain, the calls remain. A community that appears to be past the weather is still inside the event. The weak point decides how long the event stays. A distribution line is also hard to restore under widespread tree damage because repair is physical. Someone has to get to the location. The area has to be safe from active weather. Downed lines have to be treated as energized until confirmed otherwise. Trees may have to be cut. Poles may need replacement. Transformers may need inspection. Crews may have to work around flooded ditches, muddy shoulders, blocked roads, and damaged structures. Restoration is not a button. It is labor moving through damage. And in a wind swath event, that labor is needed everywhere at once. This is where a local weak point becomes a regional staffing problem. Utilities can request mutual aid. Crews can come from other areas. But mutual aid depends on roads, fuel, staging areas, weather safety, communication, and the fact that other communities may be damaged too. If the storm corridor is long, crews may not simply move into one town and finish. They may be stretched across a path where each community has its own urgent failures. The line behind the trees becomes a queue of repair orders, a queue of blocked roads, a queue of calls, a queue of households waiting for power, a queue of facilities deciding how long backup systems can hold. This is not just a tornado setup. This is a wind swath infrastructure test. The phrase matters because tornado damage and wind swath damage create different recovery shapes. A tornado can produce catastrophic damage in a narrow corridor and require intense rescue and rebuilding in that path. A damaging wind swath can produce less extreme damage at any one point, but spread it over a larger area, creating many simultaneous repair needs. One is concentrated trauma, the other is distributed strain. Both can be deadly, both can be expensive, but they stress the system differently. A distribution line is especially important because it is close to people. Transmission lines move large amounts of power over long distances. Distribution lines touch daily life. They run through the places where people live, shop, drive, work, recover, and wait. When they fail, the failure enters rooms. It enters hallways. It enters oxygen machines. It enters refrigerators. It enters traffic. It enters elevators. It enters phones. It enters the evening. The system becomes visible only after it stops working. Before the storm, nobody thanks the transformer for humming quietly on the pole. Nobody thinks about the fuse cutout. Nobody studies the service line coming into the house. Nobody asks whether the tree beside the alley has been trimmed far enough away. Infrastructure is most invisible when it is successful. Severe wind makes it visible, not by explaining it, by removing it. This is why the weak point must be named. Saying infrastructure is vulnerable is too broad. It sounds abstract. It lets the mind drift. The real story is smaller and sharper. A branch over a line, a pole at the edge of a ditch, a transformer feeding a block, a feeder circuit serving a neighborhood, a service drop connected to a house where someone needs power for health. That small component is where atmospheric force becomes human consequence. The weak point also changes with location. In a rural area, it may be the long overhead line crossing open fields, exposed to wind and hard to access after rain. In an older town, it may be mature trees growing near wires. In a suburban edge, it may be a feeder serving many homes and traffic signals. Near a hospital, it may be the connection between the facility and backup systems. Near a farm, it may be the power supply to pumps, fans, coolers, or equipment needed for livestock and storage. The weak point is local. The pattern is regional. That is why preparedness has to be local too. Before the line arrives, the key questions are practical. Are phones charged? Are backup batteries ready? Is there a plan for medical devices? Are loose objects secured? Is the car away from large trees if possible? Does the household know where to shelter for destructive wind? Does everyone understand that a severe thunderstorm warning can require the same immediate movement away from windows as a tornado threat? These questions may sound ordinary. That is exactly why they matter. Most disaster outcomes are shaped by ordinary decisions made before the dramatic image exists. A person moves away from the window. A caregiver checks the backup battery. A driver exits the highway before the line arrives. A family avoids parking under a weak tree. A facilities manager verifies generator fuel. A county road crew stages chainsaws and barricades. A utility crew prepares for multiple faults instead of one. None of those actions stops the storm. They increase margin. And margin is what a wind swath tries to remove. When the storm finally passes, the weak point is measured in what still works. If the line holds, the lights stay on, phones charge, pumps run, traffic signals work, and the household can focus on cleanup. If the line fails, every other decision becomes harder. Darkness changes movement. Heat or cold changes comfort and health. Information becomes limited. Water management becomes uncertain. Medical needs become more urgent. Food safety begins a countdown. A small failure changes the room. That is the lesson of the distribution line. It is not dramatic until it fails. It is not national until failures repeat across many towns. It is not called a system problem until enough local weak points break at the same time. But that is how wind swaths work. They do not always produce one single point of collapse. They produce many points of strain, close enough together that recovery slows. The first weak point is the line behind the trees. The second weak point is the time it takes to reach it. The third weak point is everything depending on it, while the crews are still blocked by the same storm. That is why the headline number alone is not enough. 75 miles per hour tells us the force. Corridor length tells us the reach. But the distribution line tells us where force and reach become consequence. It is the place where the atmosphere enters the neighborhood and asks whether the built environment has enough margin left. Sometimes it does, sometimes it does not. And this is not theory. A version of this mechanism has already left evidence across the Midwest. The damage did not arrive as one perfect image. It arrived as a long corridor of wind, outages, crop losses, blocked roads, and recovery that lasted far longer than the storm itself. History has already shown what happens when the wind swath is treated as secondary. This is not speculation. A version of this mechanism has already left evidence behind. On August 10, 2020, a line of intense thunderstorms raced across the Midwest and became one of the clearest modern warnings about what straight-line wind can do when it organizes, holds together, and keeps moving. According to the National Weather Service, the Derecho traveled from far southeastern South Dakota into Ohio, crossing about 770 miles in roughly 14 hours. That number should stop the story for a moment. 770 miles. 14 hours. This was not one town having one bad thunderstorm. It was a regional wind machine. It crossed state lines. It crossed farms, cities, suburbs, highways, and utility networks. It damaged places that did not all experience the same peak wind, but were connected by the same moving corridor of force. The precedent is not a prophecy. It is a system memory. The August 2020 Derecho did not become historic because every point along the path experienced the exact same destruction. It became historic because the storm system maintained a damaging wind swath across a huge distance. It produced widespread straight-line wind damage. It created extreme impacts in Iowa. It damaged power systems, homes, businesses, grain storage, crops, trees, and roads. It forced recovery to continue long after the radar line had disappeared. That is the lesson. A wind swath is not only a storm path, it is a recovery path. According to the National Weather Service office in Indianapolis, the 2020 Midwest Derecho caused 4 deaths, dozens of injuries, and damage that NOAA estimated at more than $11 billion. NOAA researchers later described it as the costliest severe thunderstorm event in recorded United States history, with damage to power poles and an estimated 37.7 million acres of farmland. Those numbers are not included to make the current setup sound identical. They are included because they show the mechanism is real. A storm complex can organize. It can maintain destructive wind. It can travel for hundreds of miles. It can produce damage more often associated in the public mind with hurricanes, even while forming from thunderstorms over land. That comparison is easy to misuse, so it has to be handled carefully. A derecho is not a hurricane. It does not have the same structure. It does not have an eye, a warm ocean core, or days of satellite tracking before landfall. It is not warned the same way. It does not arrive with coastal evacuation orders. But from the perspective of surface wind damage over a long corridor, a powerful derecho can create a broad field of destruction that surprises people because it comes from a thunderstorm line they may have underestimated. The 2020 event showed that mistake clearly. Many people understood tornadoes. Fewer understood that straight-line wind could become the dominant disaster. In central Iowa, the damage was severe enough to become part of local memory. The National Weather Service office in Des Moines reported widespread destructive straight-line winds across the state. The highest official wind gust measured was 99 miles per hour at the Marshalltown Airport, with an unofficial gust of 106 miles per hour at La Grande. Other National Weather Service summaries noted estimated winds around 140 miles per hour in parts of the Cedar Rapids area. Those are extraordinary numbers. But the most important lesson is still not only the peak. The most important lesson is the spread. A single 100-mile-per-hour gust is frightening. A long corridor of damaging wind is operationally different. It means many communities need help at once. It means power restoration is not just a local repair job. It means roads are blocked in many places. It means farms across wide areas absorb damage during the growing season. It means emergency managers are not handling one neighborhood with trees down. They are handling a regional footprint. That is exactly why the current setup has to be read with discipline. The forecast today is not a declaration that another August. It is not a promise of identical damage, identical path, identical intensity, or identical recovery. The atmosphere has not drawn that line yet, but the precedent tells us what the mechanism can do when it succeeds. It tells us why damaging wind swaths deserve attention before the damage reports begin. In 2020, the wind did not only break trees, it broke assumptions. One assumption was that severe thunderstorm warnings were secondary to tornado warnings. Another was that crop damage from a thunderstorm line would be limited and local. Another was that power outages would be repaired quickly once the storm moved on. Another was that a storm moving across the Midwest would be remembered mainly by the most dramatic tornado images. The Derecho challenged all of those assumptions. It left behind a different kind of disaster image. Not one funnel, a corridor. Not one debris field, a region. Not one emergency, a recovery sequence. When the storm crossed Iowa, the built environment became part of the story. Grain bins crumpled, Machine sheds were damaged, power poles snapped, trees fell by the thousands, roads were blocked, homes and businesses lost roofs, siding, windows, and service. The agriculture system absorbed a blow that was not only visual but economic. Fields that had been growing toward harvest were flattened or shredded. Storage and handling systems were damaged at the same time crops were damaged. That is how a weather event enters income, from atmosphere to wind, from wind to plant, from plant to yield, from yield to farm revenue, from farm revenue to debt, insurance, repair, and the next planting decision. The mechanism did not stop when the gusts ended. It moved into balance sheets. It moved into cleanup crews. It moved into supply chains. It moved into the months after the sky cleared. That is why the precedent matters for a video about the current setup. A damaging wind swath is not only an immediate safety problem, it is a timing problem. If it hits a farm during a vulnerable part of the growing season, the damage can carry forward. If it hits a utility network when crews are already stretched by other storms, restoration can slow. If it hits a city with mature trees and overhead lines, power loss can last longer than the storm itself. If it hits after dark, assessment becomes harder. The storm is short. The consequences are long. That pattern was visible in 2020. It was also visible in the way the event was remembered. People did not only talk about the wind speed, they talked about how long it took to recover. They talked about trees that were gone from streets and parks. They talked about power outages that stretched beyond the storm day. They talked about farms where the damage was not one structure, but fields, bins, sheds, roads, and equipment interacting at the same time. That is the signature of a wind swath event. It produces compound damage without needing a single dramatic point of failure. This matters because the current forecast also contains compound signals. Large hail potential can strike crops and vehicles before or within the larger wind threat. Damaging wind can knock out power while rain continues. Tornadoes, if embedded in the line or produced by earlier storms, can create concentrated pockets of more intense destruction. Lightning can delay repair. Nightfall can slow assessment. Roads can be blocked at the same time, crews need them open. None of those elements has to be historic by itself. Together, they can create a system problem. That is what 2020 proved. It proved that a thunderstorm complex can move from meteorology into infrastructure, with very little time for public imagination to catch up. It proved that the word thunderstorm does not always prepare people for the scale of wind that may arrive. It proved that straight-line damage can be broad enough to challenge power restoration, agriculture, transportation, and emergency management across a large region. It also proved that the warning is hardest before the worst image exists. Before the line hits, people see probabilities. They see colored outlooks. They hear words like damaging wind, bow echo, mesoscale, convective system, and derecho potential. Those words can feel technical. They do not always move behavior. After the line hits, the meaning becomes obvious. The power is out, the roads are blocked, the trees are down, the crops are damaged, the roof is open, the phone has no signal. The tragedy is that the proof often arrives after the best time to act. That is why evidence from the past has operational value. It gives meaning to the warning before the warning becomes personal. The 2020 Midwest Derecho also shows why the tornado frame can be too narrow. That event did produce tornadoes, and tornadoes can be embedded in derecho producing systems. But the broader damage was overwhelmingly a wind swath story. If the public only understands severe storms through tornadoes, then they may miss the event that is actually arriving. They may look for rotation while the line is already pushing wind across the surface. They may wait for a siren when the severe thunderstorm warning already carries the real threat. This is not an argument to fear every storm. It is an argument to read the hazard correctly. A tornado warning means one kind of immediate shelter problem. A destructive wind warning means another. In both cases, the safest action may look similar for the person at home. Get inside, get low if possible. Move away from windows. Avoid vehicles, trees, and temporary structures. Keep phones charged. Take official warnings seriously before the line reaches the street. History does not repeat on command, but mechanisms repeat when ingredients align. That is the careful way to use precedent. The current setup has its own timing, its own boundaries, its own uncertainty, its own storm evolution, and its own track questions. It may not produce a derecho. It may produce scattered severe storms. It may produce a shorter wind corridor. It may produce a line that weakens faster than feared. It may produce embedded tornadoes, or mostly hail, or damaging wind in a limited area. The evidence line must stay clean, but the 2020 event tells us why forecasters are right to care about upscale growth. It tells us why the phrase damaging wind swaths is not filler. It tells us why 75 miles per hour is not just a number. It tells us why corridor length and duration can matter as much as peak intensity. It tells us why the weak point may be a distribution line behind trees, not a skyscraper or a power plant. It tells us why a storm that looks like a line can become a regional recovery problem. The precedent also shows the difference between damage and recognition. During a tornado outbreak, the public often understands quickly that the event is serious because the imagery is violent and concentrated. During a derecho, recognition may lag. A long line of storms does not always trigger the same emotional response. People may have seen many lines of storms before. Some were loud and harmless. Some brought rain and moved on. The dangerous one has to be distinguished by warning language, radar structure, official reports, and behavior before it proves itself locally. That is the burden of communication. A derecho-type setup asks people to respect a threat that may look familiar until it stops being familiar. It asks them to act before the obvious image. It asks them to believe that wind without a funnel can still be the main event. That is not easy. The Midwest has a deep tornado culture because tornadoes have earned that fear through decades of damage and loss. But severe weather culture also has to include damaging straight-line wind as a first-class hazard. The 2020 derecho made that point at enormous cost. The current setup is not that event, but it belongs to the same family of risk. A family defined by organized convection, forward propagation, cold pools, rear inflow, bowing segments, severe wind reports, outage corridors, blocked roads, agricultural exposure, and recovery time that outlasts the storm. That is the system memory, not panic, memory. A good forecast uses memory without becoming trapped by it. It says, "We have seen what this mechanism can do, but we will not claim it is happening until the evidence supports it." It says, "The danger is real, but the exact path is uncertain." It says, "The storm may not become historic, but the ingredients are serious enough that people downstream should understand the kind of hazard being watched." That is the balance. The warning does not need exaggeration. The past already gives it weight. When the 2020 derecho crossed the Midwest, it revealed a simple and uncomfortable truth. A thunderstorm line can become a moving infrastructure test across hundreds of miles. It can damage crops like a seasonal economic shock. It can break trees like a landscape event. It can break power like a grid event. It can block roads like a transportation event. It can enter homes like a health event. It can keep affecting people long after the radar has cleared. That truth is why the present forecast cannot be reduced to one question. Will there be tornadoes? That is not enough. The better question is whether the storms can organize into a wind corridor that lasts long enough to make many small failures happen together. That is what history teaches. The precedent is not a prophecy. It is a warning label on the mechanism, and the next step is larger than one storm, one household, or one power line. Because if this kind of setup keeps returning in tight recovery windows, then the story is no longer only about weather. It is about whether the systems built around the old severe weather calendar can still keep up with the new load. The next step is larger than one storm. It is the pattern that appears when severe weather begins to behave less like a single event and more like repeated load on the same systems. A tornado setup can be frightening on its own. Large hail can be costly on its own. A damaging wind line can be dangerous on its own. But the system pattern emerges when these hazards arrive inside a season where the recovery window is already shrinking. The issue is not only whether one Tuesday produces severe storms. The issue is whether the roads, utilities, hospitals, farms, warning systems, and households still have enough time to reset before the next load arrives. That is the larger story. This is not only a storm setup, it is a calendar test. For decades, communities across the plains and Midwest have lived with severe weather as part of the warm season. The calendar had a rhythm. Spring and early summer brought thunderstorms. Tornado season had familiar peaks. Farmers watched the sky during planting and growing periods. Utilities prepared for tree damage. Emergency managers planned around sirens, shelters, schools, and outdoor events. People knew the season was dangerous, but they also built routines around it. The problem now is not that storms exist. The problem is that the old routine may not be enough for the new overlap. A single severe weather day can be handled if the system has margin. Crews are staged, phones are charged, warnings are understood, roads are passable, hospitals have staff, trees are trimmed, backup power is ready. The public knows the hazard and moves before the line arrives. But margin is not permanent. Margin is used up. It is used up by the last storm that left trees leaning over lines. It is used up by the last outage that delayed repairs. It is used up by the last hailstorm that damaged roofs and vehicles. It is used up by saturated ground that makes trees easier to topple. It is used up by heat that stresses people during a power outage. It is used up by nighttime timing when warnings have to wake people from sleep. It is used up by the fact that every local agency has limits on staff, equipment, budget, and time. This is where severe weather becomes a system problem. The event is weather. The pattern is recovery time disappearing. A wind swath infrastructure test does not begin when the gust front reaches town. It begins with everything already on the map before the storm forms. How many overhead distribution lines run through mature trees? How many roads have low shoulders and block drainage? How many nursing homes depend on backup generators that must be fueled and maintained? How many cell towers have limited battery life? How many homes rely on sump pumps during heavy rain? How many people receive warnings only through phones that may lose power or signal? How many farms are exposed at a vulnerable point in the growing season? The atmosphere supplies the trigger. The landscape supplies the exposure. The built environment supplies the weak points. The society supplies the unequal margins. That is the system pattern. It is tempting to describe the future only through stronger storms or bigger disasters, but that can flatten the real problem. The more operational question is narrower and more useful. What happens when ordinary systems are asked to handle extraordinary overlap? A damaging wind line after days of rain, a severe thunderstorm outbreak during a heat wave, a power outage when medical devices need electricity, a hailstorm during crop emergence, a fast-moving line during evening commute. A second storm before cleanup from the first is finished. The danger is not only one peak number, it is load repeated before recovery is complete. In the old mental model, communities often think of disasters as separate events. The storm comes, the storm passes, damage is assessed, crews repair, insurance claims begin, people clean up, the system returns to normal, then the next event happens. But that model assumes the gap is long enough. If the gap shortens, recovery becomes part of the next disaster. A tree weakened by one storm falls in the next. A roof patched after hail leaks during heavy rain. A family that used its savings on a previous repair has less ability to prepare. A utility crew, still clearing one corridor, is called to another. A county road department that already exhausted overtime faces another round of blocked roads. A hospital that handled one surge faces another night of backup planning. A farmer still assessing crop loss faces wind, hail, or flooding again. The second event does not start from zero, it starts from whatever the first event left behind. That is why this setup matters beyond its final damage report. Whether it becomes a derecho or not, whether tornadoes are few or numerous, whether the wind swath is long or shorter than feared, the operational question remains the same. Are the systems prepared for organized thunderstorm wind as a repeating regional stress? Not just as an occasional local inconvenience, this is not just a tornado setup, this is a wind swath infrastructure test. The National Weather Service notes that derechos are most common in the warm season, especially from May through August. That matters because the warm season is already crowded with other loads. Heat increases electricity demand, air conditioning becomes health infrastructure, outdoor work continues, crops are growing, people travel, schools may be out, but summer camps, sports, fairs, and evening events fill the calendar. Storms that hit during this period do not land on an empty system, they land on a system already busy. A summer wind outage is different from a cool spring outage. Heat can turn the loss of electricity into a health risk. Refrigeration becomes more urgent. Medical equipment becomes more urgent. Cooling centers may be needed. People in apartments, mobile homes, and older houses may have fewer options. If cell service weakens, information becomes harder to obtain. If roads are blocked, people cannot easily reach places with power. If gas stations cannot pump fuel, backup plans become harder. The storm may last minutes. The heat can wait behind it. That is compound risk. Not two disasters stacked for drama, but two physical realities interacting. Wind knocks out power, heat makes power loss dangerous, rain softens soil, wind brings trees down more easily, hail damages roofs, rain follows through weakened surfaces. Night hides damage, blocked roads, slow response. Each hazard changes the meaning of the next one. The system pattern is not one threat getting louder, it is multiple threats losing their separation. A tornado day used to mean tornado preparation. A wind day meant tree and power problems. A hail day meant crop, roof, and vehicle damage. A heat day meant cooling and medical vulnerability. A flood day meant drainage and roads. But real events do not always stay in those categories. A single convective setup can include hail, damaging wind, embedded tornadoes, heavy rain, lightning, outage risk, and travel disruption. The public hears severe weather. The system receives several loads at once. This is why the warning language has to carry more weight. If people hear severe thunderstorm and think only inconvenience, the system has already lost time. If they understand that destructive winds can require shelter, that changes behavior. If they understand that a line of storms can be more dangerous than one dramatic cell, that changes decisions. If they understand that a power outage can become a medical issue, that changes preparation. If they understand that a forecast with uncertainty is still actionable, that changes the hours before impact. The future will depend partly on interpretation, not just forecasts. Interpretation. A forecast can be accurate and still fail if the public reads the wrong hazard. A warning can be timely and still fail if people wait for a siren that never sounds. A severe thunderstorm warning can name destructive wind and still be treated as background noise by people trained to save urgency for tornado warnings. The pattern is not only atmospheric, it is behavioral. The atmosphere is changing the load. The public has to change the categories. Infrastructure has the same problem. Many systems were designed around historic assumptions. Tree trimming cycles, distribution design, stormwater capacity, backup power planning, road clearance staffing, hospital surge protocols, and farm risk management all depend on what kinds of events are considered likely enough to justify cost. If damaging wind swaths become more frequent in the experience of a region, even without every event being historic, then old assumptions can become expensive. A system built for scattered damage may struggle with corridor damage. A system built for recovery after one event may struggle with back-to-back events. A system built for daytime warnings may struggle with nighttime lines. A system built for tornado siren culture may struggle with destructive severe thunderstorm winds. This is the calendar failure hidden inside the forecast. The calendar is not literally broken. Seasons still exist. Storm climatology still matters, but operational calendars are built from expectations: when to staff, when to trim, when to inspect, when to stage crews, when to warn schools and event organizers, when to prepare hospitals and nursing homes, when to tell households to charge phones and identify interior rooms. If the hazards overlap more often than the old calendar assumes, the preparation schedule falls behind. That is how a storm setup becomes a future echo. It echoes into budgets. Utilities have to decide whether to harden lines, bury some circuits, expand vegetation management, improve fault detection, and stage crews differently. Cities have to decide how to manage tree canopies that provide shade but also increase wind exposure when diseased or poorly maintained. Emergency managers have to decide how to communicate destructive wind without waiting for tornado language. Hospitals have to decide whether backup systems are ready for longer outages. Farmers have to decide how to protect equipment and manage crop risk in a season of repeated convective threats. None of these decisions is simple. Everyone costs money. Everyone competes with other needs. That is why evidence matters. Overstating one forecast can damage trust. Understating a mechanism can cost lives. The correct path is harder. It says the current setup has serious wind potential. It says a derecho is not guaranteed. It says the official concern is damaging wind swaths if storms organize. It says the exact track remains uncertain. It says people should prepare for the hazard that could dominate. Not only the hazard that gets the most attention, the warning does not need exaggeration. The system risk is visible without it. Look at the chain again. A forecast mentions storms capable of wind gusts greater than 75 miles per hour. Models suggest possible upscale growth into a southeast moving storm complex. The public watches for tornadoes. The hidden number becomes corridor length. The mechanism becomes a bowing line, cold pool, rear inflow, and surface gust front. The human pathway enters a house, a hallway, a medical device, a road, and a phone battery. The weak point becomes a distribution line behind trees. The precedent becomes a Midwest derecho that proved how long recovery can last. That chain is the pattern, not panic. Pattern. The future will not be decided only by whether the strongest wind gust reaches a spectacular number. It will be decided by whether small systems can absorb repeated stress. The neighborhood line, the backup generator, the road crew, the warning message, the nursing home plan, the farm equipment shed, the cell tower battery, the intersection without power, the family that knows to shelter from wind even without a tornado warning. A system fails first at the places people rarely name. That is why the weak point matters so much. When people discuss severe weather, they often jump from the atmosphere to disaster totals, wind speed to damage, tornado probability to death toll, hail size to insurance claims. But the middle of the story is where outcomes are shaped. The middle is the local component, the decision, the tree, the line, the room, the route, the backup, the warning understood or ignored. The middle is where risk becomes real. It is also where adaptation can happen. Not every solution requires a massive new system. Some are small and practical. Better public understanding of destructive thunderstorm warnings. More precise communication about wind swaths. Stronger emphasis on interior shelter during severe wind. Vegetation management near overhead lines. Community charging plans. Backup power for medically vulnerable people. Clearer guidance for drivers. Better staging for utility and road crews. More attention to nursing homes, mobile home parks, outdoor events, and rural routes before the line arrives. Small margins can save lives, but margins have to be built before the storm. That is the future echo of this setup. The atmosphere may form one line this time, and another line later, and another after that. Each event will have its own details. Some will underperform, some will overperform, some will be remembered, many will not. But the systems below the storms will keep taking notes, whether people do or not. The grid remembers through outages, the road network remembers through blocked routes, the farm remembers through damaged fields and repaired buildings. The hospital remembers through generator hours and patient calls. The family remembers through the night the lights went out and the wind sounded like something larger than a thunderstorm. The danger is not that every severe weather setup becomes historic. The danger is that the line between routine and disruptive is crossed more often than the system is ready to admit. That line can be crossed by wind, it can be crossed by timing, it can be crossed by public misunderstanding. It can be crossed by a weak component that has been waiting behind the trees for years. The old severe weather calendar taught people to look for certain signals: darkening skies, tornado sirens, spring outbreaks, local warnings. The new operational reality asks them to look for connections: hail plus wind, wind plus outage, outage plus heat, rain plus sump pump, road blockage plus emergency delay, warning language plus public behavior, storm track plus recovery capacity. The forecast shows weather, the system receives load, and when load repeats, the question changes. It is no longer only how strong will the storm be. It becomes how much stress can the region absorb before recovery becomes the next vulnerability. That is the question hanging over the map. And before the story can end, the evidence line has to be drawn cleanly, because the worst mistake would be to turn a serious forecast into a certainty it has not earned. The worst mistake would be to turn a serious forecast into a certainty it has not earned. That is where the evidence line has to be drawn. The warning does not need exaggeration. The evidence is already enough. What is real is the official signal. NOAA's Storm Prediction Center identified a severe weather setup with storms capable of producing hail larger than 2 inches and wind gusts greater than 75 miles per hour. It also identified the possibility that storms could grow upscale into a southeast-moving mesoscale convective system capable of damaging wind swaths. That is real. What is also real is the uncertainty. The exact track of the possible storm complex is not locked in before the storms form. The exact counties that may see the strongest wind cannot be named with perfect confidence far ahead of time. The setup may produce scattered severe storms. It may produce a more organized line. It may produce embedded tornadoes. It may produce hail as the dominant early hazard and wind as the later hazard. It may weaken faster than the most aggressive scenario. It may also organize more efficiently than people expect. The evidence supports concern. It does not support pretending the future is already finished. That distinction matters because trust matters. A forecast that overstates certainty can make people dismiss the next warning. A forecast that understates the mechanism can leave people unprepared for the hazard that actually arrives. The honest position is more demanding. It says the atmosphere has ingredients. It says the wind signal is serious. It says a derecho is not confirmed. It says a derecho-like wind corridor is possible if storms organize and persist. It says the final answer will be written by radar, surface reports, warning language, and damage observations as the day unfolds. The risk is not imaginary because it is uncertain. Uncertainty is part of the risk. A person downstream does not need a guaranteed disaster to prepare. They need to understand what kind of threat could dominate. If they wait until the damage path is fully proven, the safest window may already be gone. If they prepare for tornadoes but ignore destructive thunderstorm wind, they may be ready for the wrong image. If they hear severe thunderstorm and think ordinary rain, they may stand at the window while the line is already entering the neighborhood. That is the first evidence boundary. Do not call every severe thunderstorm a derecho, but do not treat destructive straight-line wind as secondary. The second boundary is causation. One severe weather setup should not be used to claim that every damaged tree, every outage, every road closure, every injury, and every crop loss has one simple cause. Real events are more complicated. A tree may fall because of wind, but also because it was diseased, old, poorly rooted, or growing in saturated soil. A power outage may begin with a branch, but recovery may depend on crew access, equipment availability, lightning safety, road conditions, and the number of simultaneous faults. A crash may happen during the storm, but also involves speed, visibility, road design, and driver choice. The storm is the trigger. The system decides the outcome. That is why the story has to stay disciplined. The current forecast is connected to known severe storm mechanisms. It is connected to the physics of mesoscale convective systems, bowing lines, cold pools, rear inflow, and damaging gust fronts. It is connected to the known vulnerability of overhead distribution lines, mature trees, high-profile vehicles, mobile homes, farms, and people who depend on electricity. It is connected to history because past derechos have shown that organized straight-line wind can leave long corridors of damage. But connection is not the same as proof of repetition. The August 2020 Midwest derecho is not a template placed over this event. It is a precedent that explains what the mechanism can do when it fully matures. The present setup has its own environment, timing, storm initiation, boundary placement, instability, shear, and downstream exposure. It deserves attention because the mechanism is plausible, not because history is guaranteed to repeat. The precedent is a warning label, not a prophecy. The third boundary is attribution. It would be too simple to say one forecast, one storm line, or one damaging wind event proves a whole climate trend by itself. That is not how evidence works. Climate signals are established through patterns, statistics, observations, and research across many events, not by forcing one storm to carry more meaning than it can support. A single event can fit inside a broader pattern without proving that pattern alone. The clean statement is this. This setup is a severe weather and infrastructure risk on its own terms. It may also resemble broader concerns about compound hazards, compressed recovery windows, and systems built around older assumptions. But the immediate warning does not depend on making a grand claim. The immediate warning depends on wind, hail, storm organization, exposure, and readiness. That is enough. A 75-mile-per-hour gust does not need a climate argument to damage a line. A falling tree does not need a political debate to enter a bedroom. A power outage does not need a perfect attribution study to become dangerous for someone using medical equipment. The evidence is already operational, and operational evidence is the kind that matters before the line arrives. So what should be carried forward from this story? First, the public should carry the correct mental image. The threat is not only a funnel under a rotating storm, the threat may be a line, a fast-moving, organized, wind-producing line, a line that can arrive before the heaviest rain, a line that can produce destructive gusts without a visible tornado, a line that can make the safest place an interior room away from windows, even when the warning on the phone is not the warning people were waiting for. Second, the system should carry the correct weak point. The weak point is not always the largest object on the map. It may be the neighborhood distribution line behind the trees. It may be the transformer feeding a block. It may be a road blocked by one old limb. It may be the backup battery in a medical device. It may be the sump pump that stops when power fails. It may be the intersection where traffic lights go dark. It may be the cell tower that holds for a while, then loses backup. Large failures often begin as small components losing margin. Third, the forecast should carry humility. A serious risk does not become more useful when it is exaggerated. It becomes more useful when it is understood. If the storm underperforms, the preparation was still rational because the signal was real. If the storm overperforms, the preparation may be the difference between shelter and exposure. Forecasting is not about making fear certain, it is about making uncertainty actionable. That is the final line between alarm and readiness. Alarm says the worst will happen. Readiness says the mechanism is possible, the consequences are known, and the time to reduce exposure is before the evidence is visible from the window. Now return to the opening signal. Early in the day, the Storm Prediction Center flagged the setup. Hail larger than 2 inches, wind gusts greater than 75 miles per hour, a possible southeast moving storm complex, damaging wind swaths, track uncertainty, no guarantee of a derecho, no reason to dismiss the wind. At first, those are just words on an official page. Then they become a map, then a radar line, then a warning, then a gust front, then a tree leaning behind a house, then a transformer flash, then a dark hallway, then a phone battery, then a road blocked by branches, then a family asking why there was no funnel when the storm sounded so violent. That is the path of the mechanism, from the atmosphere to the room, from the room to the system, from the system to the future. This is not just a tornado setup, this is a wind swath infrastructure test. The event will pass. Every event does. The storms will form or fail to form, they will remain scattered or organize, they will weaken, merge, bow, surge, or move on. The warnings will expire, the radar will clear, the sun may return behind the line. People will step outside and begin comparing what they heard with what they see. Some places may find little damage, some may find branches down, some may find power out, some may find the road blocked. Some may find that the storm they expected to fear as a tornado arrived instead as a wall of wind. The atmosphere will move on faster than the systems below it. That is the part that remains. A community may repair the line, a road crew may clear the trees, a family may recharge phones at a neighbor's house, a hospital may switch back from backup power, a farmer may walk the field and measure the loss, an emergency manager may review the timing of warnings and reports. A utility may study where faults clustered, a forecaster may examine whether the line organized sooner or later than expected. Recovery is not just repair, it is memory. The question is whether that memory changes preparation before the next load arrives, because the next event will not ask whether the last one was convenient. It will arrive according to its own physics. It may come as heat after wind, rain after hail, another line after cleanup has barely started. A nighttime storm after people have gone to sleep, a warning that uses familiar words for an unfamiliar level of consequence. The future will not be decided only by the peak number. It will be decided by whether the system still has time to recover before the next load arrives. That is the future echo, not that every storm becomes a disaster, not that every setup becomes a derecho, not that every warning means catastrophe. The echo is quieter and more important. A world of repeated load exposes the assumptions built into ordinary life, that the power will stay on, that roads will remain open, that warnings will be understood, that storms will fit the categories people already know, that recovery will finish before the next event begins, that a thunderstorm line is less serious than a tornado because it does not look like the disaster people have learned to fear. This setup challenges that assumption. It asks whether the public can recognize a wind threat before the trees answer. It asks whether infrastructure built for yesterday's routine can handle tomorrow's overlap. It asks whether small weak points can be strengthened before they become regional cues. It asks whether warnings can move people without exaggeration. It asks whether a map can be read not only as weather, but as a preview of load. The answer will not come from one forecast alone. It will come from how people respond before the line arrives, how systems hold while the wind moves through, and how fast communities learn after the sky clears. The event will pass, but the thing it revealed will remain. A system built around old assumptions is being tested by a world no longer following the old calendar. And the next time the official signal appears, the most important question may not be whether the storm has a funnel. It may be whether the line has already found the weak point.